Okay, welcome back if you're coming from the previous video. Um, so let me just do an introduction to this series. The series is about moving from 0 to 1 on electronic designs to schematic to PCBs. How to go from your idea to your schematic to your PCB to getting it manufactured and delivered to you. Um, we're going to try to remove a lot of the upper level jargons involved. We're going to make it as simplified as possible. Um, we would start from using very crude methods to more advanced method as we go into the series. So for clearer sake, what the series is about is from 0 to 1. How can I get this done now? So the software we're going to be using for this series is EasyEDA. EasyEDA is an online software that allows builders to prototype the schematics, prototype the electronic devices, prototype the PCBs, get them manufactured in China, delivered to you in smaller quantities. You test them and you send them for bigger batches of manufacturing orders once you've verified that everything works out fine. Now they have student edition and pro edition. Different editions gives you different features. Like the name, pro edition gives you more rigorous, rugged design rule checkers. You can do more advanced designs with pro edition. But for the series, what you just need is student edition, and that's very fine. So on creating your account, you just need an email and like a username and password. You can create your account in like 5 minutes, set it up, they send you a verification mail, and you're good to go. They usually ask if you're a robot. Obviously I'm not a robot, but I go through this almost every time I log in. Yeah, so I'm logged in. The next thing you're going to do is the design. You click on design online. Now you select student edition. Like I said, both editions have different features. You can go through them, but for this series, we're sticking to the student edition because it's going to allow us to do every single thing we want to accomplish in this series. Yeah. So I'm now in, and this is where the first page we are going to see once we start. Now in the first page, you have some things by the side where my cursor is. Now this is where your projects are going to be organized based on time of creation or naming. Organized, I mean, is when I create a new project, give it a name, and I log out and log back in. If I want to access that project, I just need to go through the list of files that are by the side here. Currently, I have 2 projects I created, like just test creations before the video. But if I want to create a new project now, first thing I need to do is click on our new project, select new student project, and I give it a title. I can start with first video. I given it my title, and I can give it the description. Introducing basic concepts. This is like a readme file or something I can just glance at and understand, okay, what's the project about? And I save my project. Now after saving my project, it's going to take me to a schematic sheet or a blueprint. Now from this blueprint, you can see a borderline. This is your borderline over here, red. Now the ideal thing to do is, or the ideal thing you want to do is have your design within these parameters, within this borderline. Ensure that everything you're designing falls within this borderline. Now in some situations, which is not so rare, which is very common, you might want to break down your design into different categories. You might want to label them as power section or communication section, radio frequency section, analog section, or digital section. You can do that by chaining projects together or interlinking those sheets. For instance, I could name this blueprint as power section, and I want to design my communication section for the same project. I can just change the name by double clicking on it, change the name to communication section. Now what this does is that regardless of if they are on different sheets, they are all interlinked. I'll show you how to interlink them. But the idea is that when you transform your design, your schematic design, when you convert it into a PCB, they are all going to be represented on that PCB section. They are all interlinked under the same project. That's the very first thing to understand. If you see here, we are still in the folder first video, regardless of if you create more sheets that are all interlinked. Now, if you zoom in, we can give this particular sheet a name. We can label it as our power section. It tells us what the sheet number is and who drew the sheets. By default, it's using the account name. So that's God's Delight over here. I can change the name to a totally different thing. It gives us our date. You can change the date also. And your company. You can change the company also. Yeah. So the next thing we're looking at is after we've created our project, given it a name, selected our sheet, we now want to go through some of the common things we see on our sidebar. A common library, the first thing. Now in our common library, we see some generic symbols, electrical symbols for capacitors, resistors, inductors. We see some LEDs, some microcontrollers, some buttons. Now this just gives us like a very, very generic symbol library for majorly most of the beginner level things we would require. We can find them here. But if you want to be more specific to what you're looking for, you can go into your library. Now in your library, you can type in a very specific component name and it's going to bring it up for you. The example that we'll be using is the chip on your Arduino Uno, which a lot of us should be familiar with. The chip on your Arduino Uno, it's called an Atmega 328. Now the Atmega 328, if I just type in the name, Atmega 328, it's going to bring out different variants of Atmega 328 for me. Now, when you bring out these variants, there are some key things you need to look out for. The first thing I would mention is the price. There are some parameters we work with when we're designing a project or a board. And one of the parameters is the price of the project. Another parameter is like the form factor or the size. The price being very important because you might want to design a project and you want your project to be below $10. Remember, this is the software that allows you to manufacture your boards in China, and manufacturing is going to come at a cost. The majority of that cost is going to be from the project, the components you selected. The base board itself has a cost. Then each component being selected also has a cost. The manufacturing processes has its own cost. Testing has its own cost, and like seal screen and other things you might want to add on top of the board. But it's very important that when you're choosing your components, you pay attention to this price. They all have their tags. The same variant of boards, for instance, this one over here, this is a surface mount design or a package for surface mount design. We're going to go over packages later in the video also. So it shows you three things on the right. It shows you how the schematic symbol looks like, shows you how it will look on your PCB, the footprint, and it also shows you the real picture of the components. They put it on a surface that allows you to look at the measurement, like this is less than a centimeter in size. So we choose another variant. We also see that this one is not available. Electric one that is available. The price is way higher than the previous variants we looked at. Now, some things that can affect this price, even if they're the same components but different variants, they might have different prices. Why? Because some of those chips were produced by different manufacturers. They might have different batch quantity, or that variant might have more demand than the other variants. Their life cycle may be longer. A lot of things can affect them. The package type. Package type 2 is very important. It can affect the price of the variance. So those are one of the things you should look out for, the price. Another thing you should look out for is the availability of the component. Is it in stock? Now, there are two stock availabilities at the bottom. One showing you the LCLC stock, and the second one showing you the GLC PCB stock. Now, LCLC stock is like a over-the-counter marketplace where I can just go and purchase components and get them shipped down to where I am. Just the components, standalone components. GLC PCB SMT stock is almost the same thing, but now I can purchase those components and have them placed directly on my board. So when you're selecting a component, it is very important that you make sure they are available on both stocks. For instance, this component over here, we have 103 of them available, meaning any of our design, if we design a board and we select like 1,000, we want 1,000 prints of those boards, we don't have enough of these variants available in stock. Don't panic if they're not in stock. GLC PCB allows you to order those components. You can just message them and tell them, oh, I need more of this. We're also going to go through that along the video. But always make sure that these components are in stock. Very, very important. You don't want to finish a design and when it comes to the manufacturing, you get a mail telling you, like 7 out of your 100 components are not in stock. Do you want to select a different variant or go back to the design table? You don't want that. That's like one of the least things you want to happen to you. Something else to look out for is that you are in the either LCLC or in the GLC PCB assembly tab. User contributed. This software allows you to create your own custom chip, your own custom component. Lets you design it for the PCB footprint, schematic footprint, custom made. But key things to note: these chips are custom made, meaning they will not be listed on the stock feature. They're not going to be in stock basically. So these are just like components people wanted to use in designs. They had a variance that was not listed on LCLC and they created a package for that component and used it in their design. It was not placed on that board because that component does not exist in LCLC stock. So they got the board without the components and ordered it from a supplier, a totally different supplier, and placed it on the board. You can create your own custom components and use the same method if need be. So for now, yeah, those are the key things we need to look at in the library introduction. So after we've selected a component we want to use, or a variant of ATmega 328, we can place it on our schematic sheet. Now we have some tools in our toolbar. If you hover above any of this symbol, it gives you like an introduction of what that tool does. This one allows us to enter wiring mode. If I click on it, I can wire up different pins, connection nodes. When I right click, I leave wiring mode. Now, if I wanted to do that without visiting my wiring tools, I can just simply click on that pin and I enter the wiring node by default. When I'm done, I right click and I leave it. Or I can use a W, the hotkey, or the shortcut key, and I can enter wiring node with that. So there are also other tool sets here, like our net ports, which I can use to label a pin. I want to label this pin as pin 8. Let's see, pin 8. So what this does is, if I take this port, I copy it, and I paste it on another pin, the software recognizes this as if pin 8 and pin 12 are connected electrically. So when I convert this to a PCB, the design rule checker is going to make sure I follow this connection and connect pin 8 and 12 together. We have some flags over here to just label where our power flags would be. We can change the names of those labels by just double clicking on this and it changes. Double click on this and it changes. So like that's an idea of what our wiring tools look like. We have the no connection. If I place this on a pin, what this means is I'm updating my design rule checker. Nothing should be connected to pin 10 electrically. Meaning if I try to make an electrical connection there, I get an error or a design rule checker message saying, yo, nothing should be connected on this pin. That's the idea. So for today, these are the features we'll be going over on creating our first project. In the next video, I'm going to be doing some more in-depth features and we'll design our very first circuit. Very first circuit. The first circuit we'll be looking at is just an LED blink circuit. How to do hello world with an LED. We'll create the circuit, do some of the features, convert it to a PCB, do some really nice things around it, see it in 3D. So stay tuned and I'll be seeing you in the next video. Bye.